Good morning, students. I am Dr. Vijay Vandari. So now we are going to perform experiment number 3. So the name of the experiment number 3 is to get the data set used for analysis of polynomial regression. So now before going to proceed, what is the polynomial regression comes into our mind. So now I tell you the polynomial regressions. Polynomial regression as applied when data is not formed in a straight line. It is used to fit a linear model to non-linear data by creating new features from powers of non-linear features. Okay, so it may be in a quadratic nature, in a non-linear, and maybe in a curve. So in the first cell, we are importing necessary libraries like pandas to give structure to our data. Second is NumPy to perform mathematical and other relevant operations. And thirdly, the importing matplotlib means to create charts. Okay, so now in second cell, importing the data sets. So now we move to the Sublime text editors for better understanding. So now we importing the data sets and splitting the data set into the training sets and test set. Okay, and features scaling the next cell from sklearn dot pre-processing quoting standard scalar. So we are creating a class standard scalar from the sklearn pre-processing. So in previous video lecture, we have seen what is the sklearn used for. So sklearn scikit-learn is probably the most useful library for machine learning in Python, and the sklearn library contains a lot of recent tools for more like machine learning and statistical modeling, including classification, regression, clusterings, and dimensionality predictions. So in previous video, we have seen the sklearn that is used for and how it is used for. Now we move in the next cell, like fitting linear regression to the data sets. So now we create the class linear regression from the sklearn linear model. So now we are using this method lin underscore res methods. So creating the class linear regression, and lin underscore reg is creating the objects. It works as objects, and linear regression dot fit is a method that fits into a x comma y independent variable and dependent variables. Now fitting the polynomial regression to the data sets, and we are creating the class polynomial features from sklearn dot pre-processing. Now we are creating our objects poly underscore reg is equal to polynomial features. The degree is equal to 4. What does it mean? Degree is equal to 4. We are forming the equations in the quadratic nature, and if we want to solve these equations, and it is a form of x power of x is 4. So we keep the degree equal to 4. If we want to nth of degree is equal to 5, it will be the form of x to 5. So the equation will be a x to the power 5 plus ax to the power 2 plus ax of square plus ax to the power 1 plus ax of 0 means a. So this will be in the form of quadratic nature. Now poly.reg.fit x poly comma y. This is the fitting the poly regression, and now we are doing and performing also linear regression. So we are creating the objects linear underscore is 2 equal to linear regression is a class. And as well as a linear underscore reg2 dot fit, and we are putting the data sets into a line. Okay, so now in next cell visualizing the linear regression results. So this will be the results. The red color is denoting the by the x. This is the independent variables, and predicting the values according to a data points. So that is the getting by the blue colors. Okay, now plotting the titles. The title will be a true blood linear regressions, and plot dot x level, position level, and plot dot y level. So axis is denoting by the position level. This is the naming, and salary is naming into y11. Okay, now plt dot show is showing the plots. Now in the move, in next cell, visualizing the polynomial regression results. Now we calculate the results here. plt dot scatter x comma y comma color is equal to red. So color will be red, means denoting the x is a straight line, and the plt dot plot x mean regression 2 dot predict polyrect dot fit transform is these are the transforming the values on a y. So y is predictable. So y will the predict values. So that's really denoting by the blue color. Okay, so now we renaming the x-axis and y-axis. So x-axis is the truth or bluff polynomial regressions, and y is the position level, x is salary. plt dot show means it will show the plots. Now in next cell, visualizing the polynomial regression results for higher resolutions and smoother graphs. So these functions will calculate or will denoting the graphs and creating the graphs. Now predicting a new results with linear regressions. So printing the linear regression methods using the linear regress dot predict method applying on the data sets. Now the data sets, if we talk about the positions alien dot csv. So you can create a diagram that are plots. Now this is the data sets which we have downloaded on the UCI machine learning. Now we go to this scatter plots. This is the scatter plots, and now we select two times and finding the data sets and add trend line. And this is the polynomial graph we have generated, and which we have seen degree is equal to 4. So we change the order 4. And now click on a display equation on chart and display an r squared value on chart. This will be calculating the r squared value, and now we can see here we must closing here, and this you can find the plot. So salary is denoting by the x-axis, and y-axis is x-axis year of experience, and y-axis is denoting the salaries. So now it increases year wise, and this is called the polynomial. So r square is calculating here 0.997. This is the variance score is near about to 1, and r square, these square methods errors. So this means the error is minimal and accuracy is high. So this is the degree 4 equations, quadratic equations. So this is the a coefficient, x to the power 4 minus ax to the power 3 plus ax square minus ax. It means x to the power 0 is here, means x to the power 0 is equal to 1. So everyone knows here. So now we get the results. Now score. This is the results of. Now we first now we got the first results linear regression. This is the data points, but this data points does not fit into a line. This is the training data, and this is the test data polynomial regression. This is the final results of our data sets of polynomial regression. So these data points, this is denoted by the red, and which passes through this line, blue line. So this is the predicting values, predicting lines, and this is the actual values, which is showing by the red data points. Okay, so that's for the day. I hope you understand all the things, which is polynomial regressions, how it works, and you can run this is very easily. And if any doubt comes, so please ask. Thank you.